electric circuits ده بقى هنا charges will move in wires and around the circuit. But for any charge, in order to move in a circuit, it must have energy. And this is the role of the battery. The battery in any circuit or the power supply supplies the charges, which are the free electrons moving in the conductor, with energy. As you see, Mr. Coulomb here has no energy before the battery, and when he passes the battery, he gains energy, as you see in this red bucket. The duty of the electrons to take the energy from the battery and go to the lamp to deliver this energy. The flow of the charges through the circuit, we call it current. So the definition of current is a rate of flow of negative charges or electrons. So we want to know, how can we measure the quantity of charge? The quantity of charge is measured in coulombs. This is the unit of the charge. How many charges flow? Mr. Coulomb, one of the scientists, he placed his name as a unit in order to be well known. And the number of charges that pass a certain point in 1 second is called current. So we measure the current with a meter called ammeter. Ammeters must be placed in series, in the main branch, in order to be able to measure the number of charges flowing in 1 second. Okay, as the charges flow before and after the battery, they gain energy. So there is a difference. And when they pass through the lamp, they deliver the energy or lose this energy. So there is also a difference. This difference is called potential difference. Potential difference has a well-known name, بيقولوا عليه voltage. Voltage is, potential difference is the amount of energy transferred by the charge when passing through any component. هنبص على two definitions. The potential difference is the work done or the amount of energy transferred by the charge when it passes through the component. If the charge comes through the wire, it has electrical energy. When it passes through the lamp, it will give this electrical energy to the lamp. So the lamp will convert the electric energy into light. Now the charge has less energy. So we say that there is a potential difference. In order to make the energy gained by the battery or in the battery unique, we gave it a different name. What is the name? It's EMF or electromotive force. And this is the electrical work done by the battery to move the charge around the circuit. Normally, the charges are in the wires and they're not moving. What's the role of the battery? It pushes the charges in order to deliver the energy to whatever component is in the circuit. Both of them, EMF and potential difference, are measured in volts. What is the volts? This is the amount of energy in joules carried by every coulomb of charge. As we notice, it's called potential difference. So we must have a connection before and a connection after in order to measure the potential difference. So we use a voltmeter to measure the voltage or the potential difference or the EMF, all of them are the same, around the circuit. In order to connect the voltmeter, we must have a connection before and a connection after. The voltmeter measures the potential difference between these 2 points and tell you how much energy has been used or how much has been gained during this section. And in this area, this is called resistor. This resistor will consume some of the electrical energy or some of the voltage. So as I notice, there will be a difference between this point and this point. So the voltmeter will tell me how much voltage have been consumed in this place. Very important note you need to take care. As you notice, the charge coming back to the battery, it doesn't have energy. لازم أرجع الباتري شحات 0 volt. So when I go out of the battery, I have voltage. I will deliver it to whatever components there and go to the battery back empty-handed. No charges. As you notice also from this diagram, the charges move from positive to negative. And we call this conventional current. So the conventional current is the current flowing from what? Positive to negative. Good job. We have two types of currents in real life. One called alternating current. Alternating in English means changing. So this current changes direction. As you see, it's part of it is in the positive and other of it is in the negative. And this alternating charge is produced using a generator. The other type of charge is the direct current. The direct current, as you see, is one direction only. It does not alternate. It flows in one direction only. And this direct current is produced using most probably a battery. We're gonna watch a video now to understand more on this part.
So what is current? In this video, we're going to look at what current is in electricity, how it can be measured, and how we can calculate it.
Calculation of current is not in year 9, so when we reach this part, we'll stop the video so as not to get confused.
Current is the rate of flow of charge through a cross-section of an electrical conductor. Electric charge can also be thought of as movement of electrons. To measure current, we use an ammeter, and the unit of current is amperes or amps. A.
Another important note, in grade 9, amps is not acceptable anymore. You can either write amperes or A capital. Don't write amps, because amps is an abbreviation. Here, when you get older, we need to differentiate between abbreviation and normal units.
Ammeters must be connected in series in a circuit. The current should flow into the positive terminal of an ammeter and leave through the negative terminal. So why does charge flow, and therefore current? For electrons to flow, we need two things. 1. A source of potential difference, which is also known as voltage. This provides the pressure that makes the current flow. And 2. A complete circuit.
We have the battery made up of two wires like this, one long one and the short one. The long one is always positive and the short one is always negative.
The circuit must have no breaks in it to be complete. If there are breaks, then no current can flow. In fact, that's how a switch works. To switch an appliance off, we create a break in the circuit to prevent the current from flowing. To switch an appliance on, we close the switch which completes the circuit and so allows the current to flow. In a series circuit, so all components are in a line one after the other, all the electrons travel through every component and wire as they travel through the circuit. All the electrons experience the same resistance, and so they all move at the same rate. This means that in the series circuit, the readings on all three ammeters will be the same. A1 equals A2, which equals A3. This is not true, however, for parallel circuits. In parallel circuits, the current is shared between the different branches of the circuit.
In this part, I have a junction here. So the current coming from the main branch in A1, some of it will go to A2 and the rest will go to A3. So we can establish a rule that A1 or the reading on ammeter 1 will be equal to the reading on ammeter 2 plus ammeter 3. He's gonna clarify this in the few seconds coming.
So A1 equals A4, but A1 equals A2 plus A3, which equals A4. To calculate
we're gonna see some questions here for us to understand more on what we have discussed.
Of all things current.
Current is the rate of flow of charges. Electric current flowing in a circuit is measured using an ammeter. The unit of current is amperes or A capital. The ammeter must be measured in or must be connected in series. Now we have a circuit, all of it connected in series. We have that A2 is 0.5 ampere. So this means that all the ammeters in series must have the same reading. So A1 must have 0.5 ampere and A3 must also have 0.5 ampere. Now we have a parallel circuit. The main branch has a current of 2 amperes. When 0.8 enter the upper branch, how much will go to the lower? All the rest. So I'm going to do 2 minus 0.8, which is 1.2. Good job. And then A4, both branches, the 0.8 and the 1.2, will collect together. So they will become 2 ampere again.
Did you get them?
Okay. We can now move to the next video talking about how to construct simple circuits. Oh, actually, no. Let's talk about the types of current first before how to construct circuits.
In this video, we're going to describe what is meant by an alternating and direct current, look at the difference between them and how they can be used. Remember, an electrical current is the flow of electrons. Watch our video about current here. This is an example of direct current, or DC. Here we have a cell or a battery in a circuit. The current in a cell only flows in one direction, so the electrons only flow in one direction around the circuit. But be aware that by convention, current is a flow of positive charges, which is what you see here. The electrons which actually form the current are negatively charged, so they flow in the other direction. In this example, instead of a cell or battery, we have a mains power supply. The mains supply is an alternating current, or AC, which means the current constantly changes direction. The number of times per second the AC changes direction is known as the frequency, which is measured in hertz or cycles per second.
So this means that since the alternating current is alternating and changing, it changes at a very rapid rate. Why does it change? When we take the generator later on, I'm going to just give you a hint about it. The turbines, remembering back in energy, the turbines rotate and drive the generator to produce electricity. So the generator will also rotate. So the number of cycles the generator makes in 1 second is called the frequency of the generator. By the way, worldwide, the electricity and the AC is not constant everywhere. Some countries have 220 volts and some countries have 110. Some countries have 50 hertz and some countries have 60. Even the current, people are not, is not unified worldwide.
The frequency of alternating current,
as you see here, based on the colors, you can know the type of generator being there. In Egypt, for example, we have AC current similar to Europe, but Saudi Arabia has AC current similar to the US. This is maybe why, or this is due to the fact that the first power stations in these countries were made by different European and American countries. In Egypt, our power stations were made by, I think, France or England or UK. But in Saudi Arabia, the first power stations were made by the US. So when they made them the power station, they got them the same technology they use. It doesn't make a difference, but we need to think, why do we use AC instead of DC? That's a really important question that's going to be answered in the next few seconds. Focus.
Is different in different parts of the world. So why is our main supply an alternating current? The main reason is because it's much easier to use a transformer to change the voltage of AC than DC.
And also it's much cheaper. It's easier and cheaper. What's a transformer? We'll know now.
Transformers are used in lots of appliances to ensure that they have the correct voltage to work.
This means that the only equipment that can change the voltage, step it up or step it down, increase the voltage or decrease the voltage, is the transformer. We need to take care that a transformer changes the voltage and in return the current will be changed. But the total power will stay the same. We'll know what's power after a few minutes.
Transformers are also an important part of the national grid, allowing electricity to travel along wires and cables efficiently. For more on the national grid, watch this video. We can see on this oscilloscope the voltage or potential difference, constantly changing from positive to negative, and so driving the current in alternate directions. An oscilloscope trace for direct current would look like this.
So we noticed in the first one, it was going up and down. So it's alternating. In this case, it is constant at one value and it's always in the same direction. So this is a direct current.
There is no change in voltage, so the current is also constant. So what about this oscilloscope trace? Is it AC or DC?
Definitely an AC.
What's the maximum potential difference?
We need to take care that the maximum potential difference is the highest point. This is 200 volt. The minimum potential difference will be the same value but opposite direction, which is negative 200 volts. Okay? So now we know that there are two types of currents. And we know that current is measured using an ammeter connected in series. And potential difference or the EMF are measured using a voltmeter and it must be connected in parallel. The ammeter has a very low resistance to allow the charges to flow easy and not affect the rate of flow. The voltmeter has a very high resistance to prevent the charges from moving to the voltmeter and skipping the component. They move in the same component, but I just need to measure the amount of voltage they have or they used in this place. Since we've known resistance and voltage and current, we need to establish a connection between them. We can say that if there is a current, I can say if I have energy, I will start to flow, so there is current. If I have more energy, will I flow faster or slower? Definitely I flow faster. So we say that voltage and current are directly proportional. We can imagine a resistance is similar to مطبات في الشارع for the cars. If there are more resistance and في مطبات أكتر, the cars will have to move slower. So greater resistance will slow down the charges. So resistance and current are inversely proportional. Similar to what we said at the beginning of the year, in any triangle, any two quantities next to each other are always inversely proportional. So now we can understand what Ohm has said in his law. Ohm's law said at constant temperature, the potential difference, which is the V, at any component is directly proportional to the current passing through it. And you also must know that the resistance is measured in ohms and it has the letter omega. If you don't know how to draw the letter, you can just say, write it OHMS. In order to measure the resistance of a component, we have to measure first the current using an ammeter flowing through this component and the potential difference across this component. If I want to measure it accurately, I need to take multiple readings. So I will need to change the value of the current. The only equipment we have that can change the value of the current is called a variable resistor. This R is a normal resistor or a fixed resistor. This resistor with an arrow passing through it is a variable resistor. I can control the current by changing the resistance of the variable resistor. If I increase the resistance of variable resistor, the current will decrease. If I decrease the resistance of the variable resistor, the current will increase. طب, what are the factors that the resistance depend on? Let's go and see. The resistance of a wire is the resistance for the flow of charges. If you want to imagine the resistance, consider yourself one of the charges and this is a pipe you're moving in. If this is the original pipe and I get a longer pipe of double the length, this means it is more tiring and harder for me to finish. So the greater the length, the greater the resistance. So we say that resistance is directly proportional to the length. If I have an original wire that's narrow and the wire that is wider, the narrow wire will be hard for me to move in, but the wide wire I'll move easily. So the greater the area, the lower the resistance. In other words, we say that resistance is inversely proportional to the cross-sectional area. As we said before, there are conductors and insulators, so resistance depends on the material. When the material has more free-moving electrons, it will be a better conductor and lower resistance. If a material has less free-moving electrons, it will be a bad conductor or what we call an insulator. For example, in the video we watched a few minutes ago, they had the copper and the wood. The copper has very low resistance. It can be neglected. The wood has very high resistance that it limited the flow of the charges. We do not prevent the flow. We just limit it. This part is new in the new syllabus. We pay for electricity based on two factors, the power and the time. In order to calculate the power, power is the rate at which energy is transferred or consumed. It's measured in watts. How much energy does this component take every second? يعني إيه? If I have a lamp of 100 watts, this means that every second this lamp will take 100 joules of electrical energy. The longer you keep the lamp turned on, the greater energy transferred to the lamp. So more money will be paid. So as a result, we must know that power equals current times voltage, and energy that we pay for is power times time. The power is constant for every equipment, but the greater the time, the greater the cost. Let's see the cost of electricity. In electricity only, we use a unit a little bit different than other powers we know and energies we know in life. Normally, we use the unit joules for energy. But if we use joules in electricity, the values will be so huge and large and complicated. To make the values easier, they established a new rule or a new unit called kilowatt hour. Kilowatt is the unit for power, and hour is the unit for time. Power times time, as we noticed up here, is the energy. So kilowatt hour is what? It's the electrical energy used by a 1 kilowatt appliance in 1 hour. This definition is really important. Let's take an example to know how much will we pay for this appliance to work for 3 hours. He's telling you if the price of 1 kilowatt hour of electricity is 10 pounds, أسعار سياحية طبعا. How much will it cost to use a 3000 watt electric heater for 3 hours? First of all, the unit is kilowatt hour. So we need to convert the watts to kilowatts. We're going to divide by 1000. 3000 watts is equal to 3 kilowatts. So the energy is power times time. The power is 3 kilowatts and the time is 3 hours. So 3 times 3 is 9 kilowatt hour. This is the total energy I consumed. I know that 1 kilowatt hour is 10 pounds. So 9 times 10, I'm gonna pay 90 pounds. Something important to know about resistors. Resistors slow down the charges because as the charges move, there is friction inside. So the friction generates heat. If the current is too high, there will be overheating and this can cause catastrophic problems. It might lead to fire or explosion. So we must have any circuit with a resistance in order to prevent this problem. So a circuit without a resistance will have very large current and will have a huge problem in life. Circuits have lots and lots of components. We're going to discuss some of the components. These components, we need to know their name, their symbol, and what's unique about them. The rest of the components, you just need to know the name and the symbol, and that's it. The first component is the variable resistor, and this is the only component where I can change the resistance based on my will, on my choice. I'm not forced to for it to change according to something else. I'm the one who chooses. So what is the main purpose of the variable resistor? We write used to control the current in the circuit by changing its resistance. If he comes and asks me, how does the variable resistor work? Used to control the current in the circuit by changing its resistance. What's the purpose of the variable resistor? Same. So what we need to know about a variable resistor, it's a resistor. But I can change the current by changing the resistance of this resistor. The second component we need to know is the thermistor. This is the symbol for thermistor. Thermistor, from its name, it starts with therm, any temperature. As we notice in the graph, as the temperature increases, the resistance drops. Let's guess why. When temperature increases, particles gain kinetic energy. So they move faster. So this means there is higher current. Definitely, what causes the current to be high? The resistance have decreased. So when the temperature of a thermistor increases, the resistance of the thermistor decreases. Temperature تزيد, resistance تقل. When the temperature of the thermistor decreases, the resistance increases. Similarly to the thermistor is the LDR. LDR is the abbreviation of light dependent resistor, and that's the symbol of it. When the light intensity increases, the resistance drops. So they're the same. Thermistor relies on temperature, light dependent resistor relies on the light intensity. The fourth component is the fuse, and this is one of the components that is more common in exams. What's the purpose of the fuse? It's placed for protection. The fuse has a symbol similar to the resistor but with a wire in the middle. So it's a rectangle and a wire passing through the middle of the rectangle. It consists of a very thin wire that's very sensitive to heat or to temperature. When current increases, the heat generated is increased. So the wire melts and breaks the circuit. We can only say breaks the circuit or cuts the circuit. We cannot say explodes the circuit, blows the circuit. لا. Breaks or cuts are much better than other verbs. So why do we put the fuse? If I have an AC condition, air condition, تكييف يعني, and the current is high, it might destroy sensitive parts in the AC, and the AC is really expensive. The fuse is really cheap compared to anything in life. It's approximately £5 nowadays. So I need to keep the AC safe. So I put a fuse in the wire before it enters the AC. If the current is high, above the fuse rating, الرقم المكتوب على الفيوز, the fuse will melt and cut the circuit or break the circuit. So the high current will not reach the AC. So the AC will be still safe and not destroyed. طب, where do we put the fuse? In the wire that comes from the government. We call it the live wire. طيب, any fuse has something called fuse rating. يعني ايه fuse rating? This is the value of current at which the fuse will melt. If I have a fuse of 3 ampere, this means if the current is 3 ampere or more, the fuse will melt. If the current is less than 3 ampere, I'm working normally and nothing will happen. The last component we have this year is something called a relay. If I have a factory that have heavy machinery, this factory is controlled using a control unit. The control unit has a small circuit with small current. When current passes through this circuit, this bar becomes a magnet and attracts the switch. So the small circuit with small current controls the action of another circuit with large current. These wires go to the heavy machinery. And if I go directly and work with the heavy machinery, it will be so dangerous for anyone to work with. So as a result, we work with the small current in order to control the action of what? Of the large current in the relay. Now we have lots and lots of components. We need to be familiar with the components we are working with. These are some of the components. I'm gonna circle for you the most common components we have, and then see together what's happening. These are some of the common components we have. These two also, some of the common components. The power supplies, all the power supplies are common components we're gonna see. Ammeter, voltmeter, and a motor. All the types of the resistors and the heater. All these are components you need to know about. If you want to know them all, good job. Now we will watch two videos about the circuits and series and parallel circuits. This is the most important part throughout the whole chapter because most of the circuits in real life are made up of multiple components connected together. So if the components are not connected together, we will work with one component. I don't think anyone has one component in their home. So working with circuits is usually in series and parallel. Let's watch the videos to understand. Videos on electric circuits.
In this video, we're going to learn about types of circuits, how to draw them, and how to measure current and voltage in a circuit. There are two types of electrical circuits, series circuit and parallel circuit. In a series circuit, the components are connected end to end.
So we need to know in series they are connected end to end. They are in the same branch. This is a first important note.
After the other. They make a simple loop for the current to flow round. Note that although the negative electrons flow as shown, by convention, electric current is the flow of positive.
In grade 9, in the core, we work with conventional current, which are these arrows. The electron flow, we're not going to be asked about in the core.
Charges, so the current flows like this. We can use circuit symbols to represent circuits we use and make drawing them easier. For example, here's the circuit drawn using circuit symbols. The first step to doing this is knowing some basic circuit symbols. Using the diagram, what do you think this symbol represents? It's a lamp or a bulb. Now let's take a look at some other circuits.
Is it easier to draw the blue one or the pink one? Definitely the pink. So whenever we're asked about drawing circuits, we will draw the one on the right. Never draw something like this. These are how do they look in real life.
Symbols. Can you name any of these circuit components? Pause the video to see.
We're gonna see the same names.
Here are the names: diode, battery, fuse, lamp, variable resistor, open switch, resistor, light emitting diode or LED, ammeter, cell, closed switch, and voltmeter. Wires should be drawn as straight lines, not curved.
محدش يعمل حلزونة ما الحلزونة دي في الامتحان. Wires in real life can be bent, but in drawings they must be straight lines. Drawings are always in pencil and straight lines in case of the wires.
Pause the video and have a go at drawing this circuit diagram. How did you do? Try again with this circuit. Is this a series or a parallel circuit? How did you do? The voltage is a measure of the electrical push that a battery gives to the electrons. It's measured in volts using a voltmeter. It tells you how much energy in joules each coulomb of charge carries. Voltmeters are always connected in parallel when added to a circuit. In this diagram, the voltmeter is measuring the voltage across the lamp. We can also measure a current flowing through a circuit. We can imagine a current being like flowing water in a pipe. But instead of water, it's a flow of charge, measured in coulombs. It's actually...
So, as we notice from what he's just said, the charges are measured in coulombs.
the rate of the flow of charge. This negative charge is really a flow of electrons, and each electron transfers energy from the battery to the components in the circuit. The unit of a current is amperes or amps. It tells you how many coulombs pass per second, and it's measured using an ammeter. Ammeters are connected to a circuit in series. So there we have a basic introduction to circuit diagrams. There are two main types of electrical circuit, series and parallel. In a series circuit, the components are connected end to end, one after the other. They make a simple loop for the current to flow round. In a parallel circuit, the components are connected side by side, so the current divides.
As you see here, some of the charges move from the battery or the cell to the first lamp and go back again. So if this battery is 6 volt, the charges which went through the first branch will deliver 6 volt to the battery, from the battery to the lamp, and then go back. The other charges which moved through the second branch will take 6 volt from the battery and deliver it to the second lamp. So this means that the voltage in parallel is constant. Now in this video, we will compare 3 things together. First of all, the current in the series and the parallel, the voltage in the series and the parallel, and the resistance in the series and the parallel. Knowing that, calculation of resistance in parallel is not on us in the core. We will just take the conclusion of it in order to understand the concept. He's going to ask us about the conclusion only. He will not ask us to calculate any resistance in parallel. All the resistance calculation we will need to do will be in the series. Let's continue.
Some going one way and the rest the other way. Here's an example of 2 circuits, both containing a cell and 2 bulbs. One circuit is series, the other is parallel. The voltage is a measure of the electrical push that the battery gives to the electrons. It's a measure of the energy in joules given to each packet of electrons, coulombs. So the voltmeter measures joules per coulomb, or volts. Voltmeters are always connected in parallel when added to a circuit. In this diagram, the voltmeter is measuring the voltage across the lamp. We can also measure the current flowing through a circuit. In a wire, the current is the flow of negatively charged electrons. We can imagine it being like water flowing in a pipe, but instead of water, it's a flow of electric charge, which we measure in coulombs. So electric current is coulombs per second, or amps, measured using an ammeter, which must be connected in series. Resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. The higher the resistance, the more difficult it is for a current to flow. A good way to think about electricity is voltage as the force pushing the current around, and resistance is as if the pipe carrying the current narrows. For components connected in series, the total voltage or potential difference of the power supply is shared between the components.
This means if this is 6 volt, the electrons or the charges moving in the circuit will go and give, if these are identical, 3 volt to the first one and 3 volt to the second one. The greater the resistance, the greater the voltage will be consumed. If V1 or the first lamp has a greater resistance, it will have greater voltage. In the same example, if this is 6 volt, for example, this might take 4 and this take 2. So greater resistance means greater energy to be consumed in order to overcome this resistance and pass. If you want to imagine this idea, consider yourself running on a road and there is air coming or wind coming in opposite direction in your front. The wind will want to slow you down, but you don't want to slow down. So you need to put extra effort or extra energy in order to maintain your same flow. This is the same. The energy, as we were discussing a few seconds ago, that the charge carry is the voltage. So when there is greater resistance, the charges will pay extra energy or extra volts in order to pass. And in the series, as you will notice, that's one branch, so the current is constant.
There is the same current through each component. The total resistance of two components is the sum of the resistance of each component.
In series, the total resistance is always the sum of the components in the circuit. Add them together. And each resistor has the unit of letter omega, which is the ohms.
For components connected in parallel, the voltage or potential difference across each component is the same.
Let's see why. Those coming from the main battery going to the first one will deliver all the voltage they took because they must go to the battery empty-handed. لازم ارجع الباتري شحات. I will only pass by one component. But I need to give all the voltage I have in order to go back and take new voltage. Those going to the lower branch will deliver all their voltage to the battery and come back empty-handed. I cannot pass by both components at the same time in the parallel. I can only pass by one of them. So this means that each one of them takes the maximum voltage of the battery.
The total current through the whole circuit is the sum of the currents through the separate.
Because the main current in the main branch is equal to the current in the first plus the current in the second. So whenever we have a parallel circuit, the current in the main branch splits into the branches. So we get them by the addition and subtraction.
Components. And
the next part of the resistance, we're not concerned about it.
Let's have a go at applying some of those rules.
Let's give it a try in one of the questions to understand how things work. Little bit of a calculation.
Each cell provides a potential difference of 1.5 volts. What's the potential difference provided by the 4 cells in the circuit?
Each cell provides 1.5 volts. Now we have 4 cells. So in order to get the total voltage, 1.5 times 4, which is 6 volts.
What will be the reading on the voltmeter?
Since this is a parallel circuit, so I can easily say that the reading on the voltmeter is 6 volts. What if I want to calculate it? We have V equals IR, which is Ohm's law. I going to this resistor is 0.1 and R is 60. So 0.1 times 60 is also 6 volts. If you do it this way or that way, both are right.
The current through the lamp is 0.20 amps. The current through the resistor is 0.10 amps. What is the reading on the ammeter?
These are the current in the components. At this point, both branches collect together. So the current reaching the ammeter is the addition of both of them. So it's going to be 0.30 or 0.3.
Pause the video while you work out the answers.
As we said, 6.6 and 0.3.
When resistors are in parallel, things work out a bit different. Look at this circuit. If these two resistors were in series, then their combined value would be 3 ohms plus 3 ohms equals 6 ohms.
As we notice, 6 is greater than both of them. If I have two resistors connected in series, we add. So 3 plus 3 is 6. Let's think of another example. If I have 6 and 4, 6 plus 4 is 10. So resistance in series is greater than the greatest. بالبلدي كده لما يكون عندي resistors connected in series الريزيستنس بتاعتي تبقى أكبر من الكبير فيهم. هيورينا دلوقتي resistors connected in parallel هيحسب الأرقام. الحسابات مش علينا. احنا we need to know the final result هيبقى بكام عشان نطلع بالconclusion اللي أنا لسه زي اللي قلتها للسيريز دلوقتي.
But when in parallel, we use this formula.
مش علينا الفورمولا.
In this example, we have if 1 over r equals 2 over 3, then r equals 3 over 2.
If we look, 1.5 is less than the 3 and the 3. So whenever we have resistors connected in parallel, the combined or the total resistance is smaller than the smallest. يعني ايه؟ في السيريز أكبر من الكبير، في البارallel أصغر من الصغير. هيدينا example تاني دلوقتي ب different values.
Equals 1.5 ohms. The total resistance is lower than each individual resistor.
زي ما كنت لسه بقول لكم.
Try this one. R 5, which equals 3.
R equals 3.33. This means it's less than the 10 and less than the 5. يبقى الكونكلوجن المهمة نبقى عارفينها resistance in series أكبر من الكبير. resistance in parallel أصغر من الصغير.
3.33 ohms. How did you do? So now you know how series and parallel circuits differ and how we can calculate the resistance experimentally.
يبقى باختصار كده في السيريس current constant عشان هو one loop بس، الفولتج بيبقى divided among the components، فمفيش component هياخد الماكسيمم voltage، هياخد part of it، and the total resistance is ايه؟ the addition of the resistance. In parallel, since each one of the charge is coming from the battery and going back to the same battery, so the voltage is constant, but the current is split between them. So the total current in the main branch is equal to the current in the first branch plus the current in the second branch. The current is added together, and the resistance in parallel is smaller than the smallest. In our homes and everywhere in life, we use parallel circuits rather than series circuits for 3 reasons. First of all, each component or equipment can be switched on and off independently or separately. مش محتاج أولع كله في نفس الوقت. In series لازم أولع كله مرة واحدة أو أطفي كله مرة واحدة. If one of them fails, باظت, the rest will continue to work normally. But in the series, if one of them fails, كله باظ. Each component in the parallel takes the maximum voltage of the battery, not only part of it. So it takes the maximum voltage and stays bright. So in the multiple choice, if we have a question telling us how can we connect the lamps to gain the maximum brightness or to stay with highest brightness, they must be connected in parallel only. Last part is not last part, part before the last. Potential divider. This is similar to raising the brightness or lowering the brightness of your screen on the phone. If you want to raise the brightness, you push the pointer up. If you want to lower the brightness, you push the pointer down. If I push the pointer up, I'm increasing the length from A till P. If the length increases, resistance increases. When the resistance increases, voltage increases. So the voltage reaching the lamp will be higher, so the lamp will be brighter. طب دي حاجة حلوة. But there's a problem. If the lamp is brighter, it's taking more energy per unit time. So as a result, the battery will drain faster. If I move the pointer down, the length decreases. When length decreases, resistance decreases. And when resistance decreases, voltage to the lamp decreases. And the lamp becomes dimmer. In other words, شوف الكونكشن دي بتبتدي منين اللي رايحة لللامب؟ ده الزيرو. بعد كده يبقى at A 0 volt. At C maximum voltage هو زي بتاع الباتري بالظبط. And this between A to C the voltage increases from 0 to maximum أو لو من C ل A from maximum to 0. That's all what we need to know about potential dividers. The common hazards of electricity or when dealing with electricity are general knowledge in some way. What might be the problems we might face with electricity? It's one of two things. Either an electrical fire due to overheating or having electric shock, electrocution, something like this. So what might cause an electric shock? Touching a bare wire or a wire with damaged insulation, because my hand will be in contact with the conductor. So the charges will move in my body, so I will get an electric shock. If I use electricity and my hands are wet, or if water comes in contact with electricity, water has ions. So the ions will allow the charges to move through my body easily, causing me to get an electric shock. The second one is overheating of the cables, which might lead to fire. If we have a wire carrying current, it produces heat. When the current becomes too large, the heat becomes so huge, so it causes overheating, and sometimes it might lead to fire. And if I have one socket and I put like lots of extension cords, مشتركات كتير في one socket, this socket will have so much, so the current in this socket will be so high, causing overheating and sometimes might lead to an explosion. For overloading of plugs or adapters is really critical. We shouldn't do this. Like maximum one or two. Don't overload a plug. Electricity comes to our homes in 3 wires. That's not in Egypt, بس مش مهم. One wire comes, and assuming this is the government, power supply from the government, and this is our washing machine at home. The current comes from the government in the live wire, and it's brown, as we see in this diagram. And this wire has all the voltage. All the voltage is in the live wire, because the live wire gets the current from the government. The neutral wire completes the circuit. It sends back the charges to the government to gain voltage and come again. So the neutral wire must always be at 0 volt. If the neutral wire has voltage, it can cause a major problem. And both wires are connected to the motor of the washing machine. The third wire is the earth wire. It's connected to the metal casing. If you have a socket with 3 cables, the third cable اللي بيبقى في النص لوحده ده يبقى دايما السايز بتاعه اكبر شويه. ده بيسموه الايرث واير. الكالر بتاع الايرث واير بيبقى يلو اند جرين سترايبس، وده بيبقى كونكتد للميتال كيسنج. ليه؟ just in case، لو لا قدر الله يعني the live wire touches the metal casing. لو انا جيت استخدم الغساله the charges will move through my body and I will gain electric shock. So the purpose of the earth wire ان هو ياخد الشارجز بدالي من هنا كده وينقلها للإيرث، فأنا ما اتكهربش. يبقى we have 3 wires: live wire, neutral wire, و earth wire. Live is brown, neutral is blue, earth is yellow green. The most important part في for this section is that the live contains the fuse, circuit breaker, and the switch. If you have your notes, highlight this sentence because this is really important and it's questionable part. بيجي عليه questions كتير. طب let's imagine if I have a hair dryer made of plastic, will I need the earth wire? No, because if the live wire touches the plastic is an insulator, it will not allow the charges to come to me, so I will not get an electric shock. So the earth wire is only available if the equipment is made of a metal casing or contains metal, not plastic. والحمد لله, end of the chapter of electricity.